Welcome back, dear student. I hope the last session has been helpful for you all. We are into the new topics and let's check it out. What is our new topic for today? Our new topic for today is the graphical representation of motion. Generally, newspapers and magazines use different types of graphs to represent the information in an interesting way. They often use to describe the motion of an object, we can use line graph in case line graphs show dependence of one physical quantity such as distance or velocity on another quantity such as time. Distance time graph. To draw the distance time graph for the given data, take a sheet of graph paper and draw two lines perpendicular to each other on it. Now mark the horizontal line as XOX dash. It is known as the x-axis. Similarly, mark the vertical line YOY dash. It is called the y-axis. The point of intersection of XOX dash and YOY dash is known as the origin. Decide the quantity to be shown along the x-axis and that to be shown along the y-axis. In this case, we take the time along the x-axis and the distance along the y-axis. Now choose a scale to represent the distance and another to represent the time on the graph. For the motion of the car, the scale could be x-axis 1 centimeter is equal to 1 second and y-axis 1 centimeter is equal to 5 meters. Mark values for the time and the distance on the respective axis according to the scale we have chosen. From the table, the set of values for time and distance are 0, 0, 1, 5, 210, 315, 420, 525, 630 and 735. The first number of the set represent time and the second number represent the corresponding distance. To mark the set of values 0, 0, look at 0 on the x-axis and 0 on the y-axis. This point is the origin. To mark a point for the set of values 1, 5, look for 1 on the x-axis and draw a line parallel to y-axis passing through this point. Look for y on the y-axis and draw a line parallel to x-axis passing through this point. The point of intersections give the point that represent 1, 5, as you can see on the screen. In the same way, mark the points corresponding to the different sets of values as shown in the image. Join all the points on the graph. It is a straight line which is the distance time graph for the motion of the car. If the distance time graph is a straight line, it indicates that the object is moving with a constant speed, that is uniform motion. However, if the speed of the object keeps changing, the graph can be of any shape, that is non-uniform motion. So, we can say that the distance time graph indicates the time of motion, whether it is uniform motion or non-uniform motion. Hence, we can conclude that the distance time graph gives information about the distance covered by an object in a definite time interval and also the distance covered by an object at any instant of time. Calculation of speed using distance time graph. How we calculate the speed using distance time graph? The distance time graph can also be used to find the speed of an object at any instant of time. To find the speed of an object, consider a small part AB of the distance time graph shown on the screen. Draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now on the graph, AC denotes the time interval T to T1 while BC corresponds to the distance S to S1. Now as you can see, the average is speed is equal to s2 minus s1 by s2 to st1. Speed gives the idea of how fast the body moves. In general, body moves in a particular distance direction at an instant of interest, and this direction may not be constant throughout the journey. Now let's come to the velocity time graph. The change in the velocity of an object with time can be represented on the velocity time graph. In this graph, velocity is taken on the y-axis and the time is taken on the x-axis. Let's take case 1. For an object moving with uniform velocity, the graph will be straight line parallel to the x-axis. This is because the velocity does not change with time. The distance traveled by the object between the points A and B with velocity 20 km per hour is determined by the following steps. Let's see what are the steps. V is equal to speed by time. S is equal to Vt. We know that V is equal to 20 km per hour is equal to AC or BD. Check in the graph. T is equal to T2 to T1. Therefore, S is equal to AC into T2 to T1 is equal to AC into CD, or S is equal to area of the rectangle ABDC. Case 2. For an object whose velocity is increasing with time, the graph is a straight line having an increasing slope. This is because the velocity increases by equal amount with equal intervals of time. The area under the velocity time graph is the distance of the object, that is the magnitude of the displacement. The distance traveled by an object between the points A and E is the area ABCDE under the velocity time graph. S, that is distance, is equal to area of ABCDE. So the S is equal to area of rectangle ABCD plus area of triangle ADE. S is equal to AB into BC plus half into AD into DE. Case 3. For an object whose velocity is decreasing with time, the graph is a straight line having a decreasing slope. This is because the velocity decreases by equal amounts in equal intervals of time. Case 4. For an object whose velocity is non-uniform, the graph shows different variation. This is because the velocity changes by unequal amount in equal interval of time. I hope the concepts of graph is clear now. Hope we'll continue with the next topic, that is representation of equation of motion on graph. Thank you so much.